China's most dangerous $31 billion project. A dam so massive, it holds back one of the most powerful rivers on Earth. Every second, millions of tons of water push against this wall. If it fails, the destruction would be unimaginable. Entire cities would be gone, and millions of lives would be at risk. And yet, it was built anyway, because if it works, it can power entire regions and control floods that have killed for centuries. This is the Three Gorges Dam, one of the most dangerous and unreal engineering projects ever built. For thousands of years, this river controlled everything. The Yangtze stretches over 6,000 kilometers across China, and along its banks, hundreds of millions of people live. But this river is not just a lifeline. It is unpredictable, violent, and at times catastrophic. Floods have killed hundreds of thousands of people, wiping out entire regions in days. Cities were destroyed, farmland erased, and infrastructure lost. And the worst part was that there was no way to stop it. Until China decided to change that, not by adapting to the river, but by turning it into a system they control. So they built something on an entirely different scale. The Three Gorges Dam is a structure stretching over 2 kilometers across the river, rising more than 180 meters high, and built with tens of millions of cubic meters of concrete. It holds back a reservoir so massive that it stretches for over 600 kilometers upstream. This is not just a dam. It is a system designed to control water itself, a wall between chaos and control. This was not just an engineering decision. It was a political one. For decades, this idea had been debated. Because the scale was extreme. Controlling a river like the Yangtze means controlling billions of tons of water, and that comes with risk. This structure does not just hold water, it holds pressure. At its base, the pressure can reach over 10 million newtons per square meter. That is like having the weight of an entire truck pressing onto a surface the size of your hand, constant and relentless every second. If something fails, if the structure cracks or the system loses control, everything downstream is exposed. Cities, infrastructure, and millions of people would be affected. This is not a local risk, it is a national one. And yet, they moved forward because the potential reward was just as massive. But this kind of control comes at a cost. The project cost around $37 billion. It is one of the most expensive infrastructure projects ever built. A multi-billion-dollar bet against nature itself. But building something like this starts with a simple question. How do you even begin? Because you cannot just build a dam in a flowing river. The first step was to move the water. Massive diversion channels were dug to redirect the river around the construction site, while temporary dams called cofferdams blocked the original flow. Only then could construction begin. What followed was one of the largest construction efforts ever. Tens of thousands of workers operated around the clock, pouring the dam layer by layer in concrete, more than 28 million cubic meters of it. But building at this scale creates another problem: heat. As concrete hardens, it generates internal heat, and if not controlled, cracks form. So engineers installed cooling pipes deep inside the structure, allowing cold water to flow through them and pull heat out of the concrete. This controlled the temperature while the dam was still being built. Piece by piece, year by year, the structure rose until the river was no longer in control. All that water is not just being held back, it is being used to generate electricity. This dam is not just a barrier, it is a power plant. Inside the dam, water is released through massive intake tunnels and flows downward through huge pipes called penstocks. As the water drops, gravity accelerates it, increasing speed and building pressure. At the bottom, this high-speed water hits the turbine blades, forcing them to spin. These turbines are massive. Each one weighs over 600 tons, blades larger than a bus, spinning deep inside the structure. And all of it is hidden. You don't see any of this from the outside. These turbines are directly connected to generators, and as they spin, they rotate massive coils inside magnetic fields, creating electricity. The faster they spin, the more energy is produced. But the flow isn't constant. It's controlled. Gates inside the dam regulate exactly how much water passes through each turbine, adjusting output in real time depending on demand. At full capacity, the Three Gorges Dam uses more than 30 turbines to generate power. producing over 22 gigawatts of energy. That is enough to supply millions of homes at the same time, all powered by moving water. But using the river like this creates a new problem. The Yangtze is not just energy, it is one of the most important transport routes in China. Every year, over 100 million tons of goods move along this river, and entire supply chains depend on it. The moment you build a dam, you block everything. Ships can no longer pass, and trade stops. So engineers had to solve another problem. How do you move ships over a wall more than 100 meters high? The first solution was a system of locks. Ships enter one level, the water rises, and lifts them step by step over a total height of more than 100 meters. But it is slow. Moving a single ship can take up to 4 hours, which is too long for modern trade. So they built something else. The Three Gorges ship lift lifts ships in a completely different way. Instead of lifting the ship directly, it lifts an entire water-filled chamber. The ship enters this chamber while floating normally, and once inside, nothing changes for the ship because it is still floating in the same water. Together, the water, the steel structure, and the ship reach a total weight of over 15,000 tons. The entire chamber then begins to move, guided along vertical rails on both sides of the structure. The system is powered by motors, but most of the load is balanced by massive counterweights that move in the opposite direction, reducing the energy needed to lift the system. The chamber rises more than 100 meters into the air in just 30 to 40 minutes. But even after it was completed, the system kept changing. Every year, the Yangtze carries massive amounts of sediment downstream, sediment that normally builds fertile land and supports ecosystems along the river. Now, the dam holds much of it back, slowly changing how the river behaves. But the biggest change happened long before that. To create this reservoir, entire regions had to disappear. Cities were flooded, villages erased, and more than 1 million people were relocated, forced to leave behind their homes, their history, and their lives. Even today, the landscape remains unstable. The rising and falling water levels along the reservoir weaken the surrounding slopes, increasing the risk of landslides. And there is something else: the sheer weight of the water stored behind the dam, billions of tons pressing down on the earth. In some cases, this has been linked to increased seismic activity in the region. Small shifts, subtle changes deep underground, not always visible, but always there. And then there is something almost nobody talks about. The weight of this water does not just press down on the earth beneath it. It changes how the earth moves. When the reservoir filled, more than 39 trillion kilograms of water shifted from the lower river basin to a higher elevation behind the dam. That redistribution of mass works the same way a figure skater slows their spin by spreading their arms. The rotation of the entire planet adjusts. NASA calculated the effect. The Three Gorges Dam lengthens a single day on Earth by 0.06 microseconds. Too small to feel, too small to measure without instruments built specifically to detect it. But real, a structure built to control a river ended up changing the rotation of the planet itself.